Hello and welcome back to lesson number 6. For this lesson I'm going to be talking briefly about glob, which is an incredibly useful package and one of the best names of packages in the Python ecosystem. And I'm also going to talk a little bit about matplotlib and some more advanced things you can do with it. Okay, so first of all, glob. What's glob? Well, it's a package that comes with Python, so you should all be able to install it without having to use pip install. You import it like so, and it just has one function that we're going to use, which is called glob. glob.glob. What this does is it pattern matches with file names in your current directory by default, but you can look in other directories as well. So we can tell it to tell us anything that ends with .txt. We're using wildcards here, much like they are used in the ls command in Bash, for those of you that have experience with Linux or Mac. What this will then do is it will fetch all of the files in our current directory or in the given directory that end in .txt and return them as separate strings in a list to the user. So we can say all sim files. Okay, cool. That's great. So what do we do with it? Well, now that we've got this information, we can use the matplotlib plotting skills we've got to plot all of the simulation files on a single plot to see just how much they vary. So first of all, we're going to import matplotlib.pyplot as PLT. We're going to need to pass the data, so we're going to use numpy as well. And then we're going to say for sim file in all sim files, to create a for loop. We're going to add in some other things, but just before we do that, and before I forget, we need to remember to turn on interactive mode for the matplotlib plot. Now let's create a figure. Let's create some axes on that figure. Just as I've shown you so far, you can see this is what the figure looks like. Now, all I need to do is write this for loop. So for sim file in all sim files, you can say the data is equal to np.loadText, and then we just provide the sim file name and skip rows of 52. Now we've got x is equal to sim all the rows first column, y is equal to sim all the rows second column, and z is equal to sim all the rows third column. Now we've got all the data, so now we just need to do a cross section through it. So we do that by finding the smallest y value. So what we can do is say, okay, x is equal to x, where y is equal to np.amin. So we're taking the smallest value of y. Well, the lowest value of y after making sure that we've absoluted it. Then we can do the same thing with z. And with that, we have extracted the cross-section for the luminance in every simulation file. And now all we need to do is x.plot, x on the x-axis, luminance on the y-axis, and let's put a label in as well. I'm going to say label equals, and let's just make sure that each one is labeled with the simulation file. There we go. Now let's execute that for loop. Now you can't really see it because it's not on the screen, but there we go. The figure has now plotted every single one. But which one is which? How do we know? Well, that's why we've included this label. Because the label will correspond to the file name. All we need to call is x.legend, and we don't need to provide any arguments, but I'm going to say location equals best, which will automatically put the legend in the best location that covers the least amount of data. And if we look back at it, we can see we've got a legend up here in the top right now. tells us which files belong to which. This is pretty powerful, as I'm sure you can imagine. Now the thing is, we can actually do a bit more with this. Like, this is great and all, but we can do quite a bit more to our matplotlib plot, things that we haven't really covered so far. For example, one thing we can do is set the labels. So we can say x.set ylabel, and then we can provide a string. It's going to be luminance, and the units are candela per meter square. So I'm going to use LaTeX here, for those of you that know how this works. And it is candela meters to the power of -2. Close square brackets, close quotes, close brackets. And this luminance candela per meter square will now appear in math format on the image. So if we look at this, you can see it's a bit hard to see here. If we expand it, you can see we've got superscripts going on and everything is italicized. This is quite useful. I can do the same thing for the X label. Position, millimeters. In fact, we want to probably make clear that this is X position. So, X position, millimeters. Close brackets. Now, if we look back to our plot, we've added an X label here as well. We've got the Y label and the X label. Now we just need a title. Set title. What should we say? Probably that this is a luminance cross-section plot. There we go. And now we have set the title on our plot. And this is quite powerful. We're building up quite a lot of things regarding our plot that we didn't have before. In fact, we're probably quite happy with this. We're basically done. So what we can do is then save it. So we say fig.savefig, and then we provide some kind of file name. So my multiple line graph.png. Then that will save the figure in a folder, which we can then open. So I'd recommend you try that yourselves. We can also call it exactly the same thing as our simulation file. It's quite powerful, but basically we've got a lot of things going on that we can augment our plot with. And that really is it. There's quite a lot you can do in matplotlib. There's quite a bit more in the notes about things that we do and we show you can do. So have a go at the exercises. Now note that these exercises are a little special because they're actually fairly straightforward, but they require a lot of creativity from how to treat them. You're not expected to just go through the notes and rewrite everything exactly. It's more of an expectation that you'll go through and use the materials that you have available to you. I can guarantee that the first exercise can be finished in under a minute if you're quick. Just need to make use of the notes that are in the exercises and what they already do. So please take some time to go through those and make sure you understand what they're doing before you leap into the exercises. Alright, I'll see you in lesson 7.